Today, me and my team are going to present about our research, and the title is The Research of Mortar Mixed with Different Type of Sand. My name is Rabiatul Adawiyah. For this research, we will replace the river sand that is used in mortar mix with foundry sand and polluted sand that we got from ES Jesselton Engineering Sendirian Berhad and from Polytechnic Kota Kinabalu Brick Workshop. For this research, we will be using two types of foundry sand, that is ferrous and non-ferrous.
Hello, my name is Sylvia Najudin, and today I will going to present about the problem statement for our project. Construction industry has been increasing rapidly, so more materials needed to carry on the project, and demands for mortar will increase. The cost of materials project increase because the lack of raw materials such as cement, sand, and aggregate. We also want to reduce the use of new sand instead of prioritize the reuse of polluted and foundry sand in the mortar mixture. The objective of our project is: first, we will determine the silt and sieve analysis of sand. Second, we also want to determine the physical properties of mortar cube. Last but not least, we also want to determine the mechanical test of mortar cube. So, the findings for silt test result, it shows that 2.5 silt content for river sand, while the polluted sand has 3% of silt content. So it shows that river and the polluted sand do not have a lot of amount silt content that more than 6%, which will cause the weakened bond of cement and sand. Next, the foundry sand, for ferrous and non-ferrous, it shows 0% of silt content, where this can be concluded that the foundry sand will make a strongest bonding with the cement in the mixture of cement mortar because it has no silt content. So, from this graph, it can be concluded the fineness modulus of sand. So, the fineness modulus of sand shows that the non-ferrous has a 2.0, polluted sand has 2.4, while for the river sand it has 2.2. So it can be concluded that the non-ferrous, polluted sand, and river sands are in the fine sand, while for the ferrous it is in the coarse sand.
Density analysis, we can see that river sand and polluted sand are the same, that is 2016.13 kg per meter cube. The density for ferrous is 2419.36 kg per meter cube, and for the non-ferrous one is 2822.58 kg per meter cube. From the graph, we can see that non-ferrous sand has the highest average density, and it is followed by ferrous sand. And for the polluted sand and river sand, it has the same average density. The reason why we must know the density of cube is because the mechanical properties are highly influenced by its density. A denser mortar generally provides higher strength and fewer amounts of void and porosity. The smaller the voids, it becomes less permeable to water and soluble elements. So water absorption will also be less and the mortar have better durability. In conclusion, the strongest mortar has the greatest density because it contains the largest proportion of solid matter. In this case, we can see that non-ferrous sand has the highest average density.
My name is Shasha Arisia binti Hussein Chok, and I will be presenting about compression test. This is the graph for compression strength of polluted sand. In 7 days, we can see that the compression strength is 604.4, while in 28 days, the compression strength is 806.4. Next, the compression strength for foundry sand ferrous. In 7 days, the compression strength is 265.8, while in 28 days, the compression strength is 201.2. The compression strength for foundry sand non-ferrous in 7 days, compression strength is 64.4, while in 28 days, the compression strength is 447.4. This is a graph about the comparison between polluted sand, foundry sand, ferrous, and foundry sand, non-ferrous. We can see from this graph, the most highest value is polluted sand, which is in 7 days, it is 604.4, while in 28 days, it is 806.4. 66.4.
Hello, my name is Shirley Severinus. For this test, we have conduct the samples that curing for 7 days. From here, tables 1, you can see the result water absorption in Foundry Sand, which is ferrous and non-ferrous. Tables that we get from our result is you can see here. For the next finding that I get is water absorption for polluted sand and river sand. Based on the figure 2, shows that both of polluted sand and river sand have the same value of percentage, which is 25% for the water absorption. It is in the constant state from the previous sample. We can assume that both of these sand have the similar physical properties as for the strength and the permeability. The result of the project shows that polluted sand and river sand can be used to replace hardware sand, except for the Foundry Sand, because the results showed that it has the lowest compressive strength. The following are the recommendations carried out to the next stage of our project. As for the conclusion, polluted sand and river sand can be reused without losing its properties.